Okay, this video is about my attempts to write a computer program for the Mattel Aquarius. When I first got this computer nearly 40 years ago, I wrote quite a few games for it, but unfortunately through time I've now lost them. One of the things that always infuriated me about the machine, however, was its speed in BASIC, because that's all I knew at the time, and you can only write very slow games. What I've decided to do is to learn a little bit of Z80, and I have challenged myself with writing a Z80 game, well, Z80 subroutines, and to see if I can write a faster game for the Aquarius. And I've also challenged myself to write it for the unexpanded Aquarius as well. Now, unfortunately, it seems to have picked up a bit of a flutter. I mean, the flickering screen you can see there, that's just because it's a CRT. What I might do is insert some screen grabs from Virtual Aquarius, which is where I wrote this program, and this is basically the first time that I'm trying it on this computer. But it seems to have picked up a bit of a power supply issue, but I'll fix it after I've done this video. Alright, so the machine's running there as it is. Okay, so the unexpanded Mattel Aquarius having only 1.7 kilobytes of RAM. This was in an era when computers had an absolute minimum of 16, and the likes of the Spectrum and Commodore 64 obviously had 64. So for Mattel to attempt to release a computer that only had 1.7 available led to its swift demise. Right, so I'm going to try and show you loading the first section. So I just need to get the sound file, which is that one. Okay, so the game's called Quaid, so it's loading Quaid Part 1. It should take about 20 seconds. Oh, here we are. I can now run that. So, Control 1, press return. So it loads up a simple little welcome screen, if you like, a little bit of text that tells you about the game, and then it jumps straight into the load for the second part. So if I press return there, and then rip on part 2. Okay, if I list that now, Quaid Part 2, you can see that there's basically about 2.5 pages of code there. If I attempt to bring the free memory back up again, can't do this one-handed, please excuse me. You can see I have 157 bytes free. Now that is pretty much the lowest I can go to. If I try to use any more memory, when you actually run the program, it'll start kicking up out of memory errors. Right, I just need to retune this TV. Right, I'm definitely getting a voltage drift issue, I think, on this machine. Anyway, now to run part 2. So part 2 was like this. Okay. Now I've basically written 4 machine code routines. The first one changes the background colour quickly. The only way of doing it, if you try to do it in BASIC, the only option is to write a for next loop, which takes about 7 or 8 seconds to change the colour of the screen. So I've got a machine code routine that does that pretty much instantly. I've then got a second machine code routine which only colours this part in here. And I've actually utilised that as part of the game over routine, which you'll see later on. There's a third machine code routine that does laser beams across the screen. And then there's a fourth routine that actually handles the aeroplanes coming across the screen. So how the game Okay, right, so here we go. I just want to show you a little way around the listing. Basically, at 2000 there's the machine code loader. At 4000 there's like an intro screen which is done using a utility that was available on a web page. I'll try and put a link to that if I remember. What follows is basically the same code that was in the 1.7K version, just with some extra pokes here and there to give it some graphical enhancements. Obviously there's no remark statements in here, and there's no spaces between the commands, because at that time memory was everything, and spaces and remarks would have used valuable memory. Okay, so there's the first page. Yeah, I changed missiles to power reserve, which was what we wanted. And it goes down, and okay, so this section here is a rather dirty set of commands that write the game over on the screen. The next bit is the machine code loading routine, including the necessary pokes you need to do to reserve the top end of the memory so that your basic doesn't trample all over it. That loader screen I was talking about, this was just copy and paste off his website once you've actually done the drawing that you want to do. And you know, obviously all of that wastes memory, but by this point I decided this was the 16K version and I was quite happy to do that. If I have a look to see how much memory I've still got left, yeah, I've still got 8.2K left, so doing alright. Right, okay, so you should see some differences with this version. So that's loading machine code now. This is the graphic screen routine that you saw. It's written in BASIC, so it's a bit slow, but you can see that you know, it produces a reasonable graphic there. Okay, so press any key and that takes us back into the game, which you might remember, but with better graphics here, a little guided control desk down here, but then after that it goes back into pretty much the same thing. So if I press start, I've actually increased the start speed on this one, so at the beginning of the game's not quite so dull. So 9, 8, 1, 5. Yeah, you can see they're coming much faster initially than they were in the other version. I might go back and put these modifications back into the 1K version. But anyway, and the big difference now, the only big difference remaining is that when you die, it writes game over in big letters, and that was what all those big list of pokes were in the middle of the screen. So there you go. My attempt at writing a machine code enhanced game for the Mattel Aquarius. Just an aside as to my method of Z80 programming, which is a bit old school, in that I'm writing out the code that I want by hand, and then converting it to code. So for example, I've got load A with 27 here, so load A is 62, so load A is 62, and then 27, that's hex 27, becomes 39 in decimal, and basically just going through like that. And then these are the numbers which I'm putting into a data statement, which then gets poked into the relative locations on the Aquarius, and then I call the first location, and hey presto, it does the rest of the work. And that's how I've been approaching this game, and a few other little daft bits and bobs as well. Bit messy, very time consuming, but it's just the way I wanted to do it, because I wanted to get a true understanding of how it all worked. I'll try and put a link to everything in the description, and you can have a look at it and see what you think. But it's my first attempt. Don't judge me too hard. That's it. Game over.